1907. A cotton mill town in South Carolina. The air smells of wood smoke and boiled cornmeal. Inside a cramped mill house, a woman sits by a window, her hands trembling, her skin cracked and blistered across her neck and forearms like sunburn that never heals. She has not been in the sun. Down the road, in the county asylum, dozens of patients scream through the night, gripped by a madness no doctor can name. Some cannot remember their own children's faces. Some simply stop speaking. Some die. Doctors call it the Mississippi disease, the Italian sickness, the disease of the poor. Nobody understands it. Nobody knows what causes it. And in the American South, in a single generation, it will sicken 3 million people, and it will kill at least 100,000 of them. The doctors will blame spoiled meat. They will blame heat. They will blame moral weakness, laziness, even race in the ugly logic of the era. They will blame everything except the one food sitting on every poor Southern table, 3 times a day, for years on end. A steaming, golden, comforting pile of cornbread. Corn, the crop that had fed the poor for generations. The crop stacked in every crib and silo from Georgia to Texas was, in some hidden way, killing them. And the strangest part of the mystery was this. People in Mexico had been eating corn as their primary food for 9,000 years, and they never got sick like this. Something had gone wrong. Somewhere between the fields of ancient Mexico and the mill towns of the American South, a piece of ancient knowledge had been lost. And it would take a stubborn, unpopular government doctor, willing to eat pellagra patients' scabs to prove a point, to figure out what. To understand what killed those southern mill workers, we have to go back. Not decades, not centuries, 9,000 years to a river valley in southern Mexico, where a nearly inedible wild grass would begin the strangest, most consequential transformation in the history of human food, and would end up, one way or another, feeding half the planet, fattening billions of livestock, fueling millions of cars, sweetening nearly everything Americans drink, and quietly deciding the outcome of wars, empires, and elections along the way. This is the story of corn. And by the end, you will never look at a cornfield, a bag of tortilla chips, or a gas pump the same way again. Picture the Balsas River Valley in what is now the state of Guerrero roughly 9,000 years ago. Steep green hills, humid air thick with insects. A wild grass called teosinte grows in scattered clumps along the riverbanks. Its stalks thin, its ears barely the size of a human thumb. Pull one apart and you'll find a handful of hard, stony kernels wrapped in a shell so tough it could crack a molar. This is not food. Not really. It is barely worth the effort of harvesting. And yet, somewhere in these hills, small bands of early Mesoamerican people begin doing something patient and strange. They notice that some teosinte plants happen to have slightly larger kernels, slightly softer casings, slightly more grain per stalk. They save those seeds. They plant them again next season. And they do this again and again for generations. Nobody among them will ever see the end result of their work. This is a project that spans not a lifetime, but dozens of lifetimes, an act of faith passed silently from parent to child, season after season, with no written instructions and no guarantee it would ever amount to anything. And then, quietly, biology hands them a gift. A random genetic mutation appears in a wild population, softening that stone-hard outer casing that had made the grain almost impossible to eat. Ancient farmers who noticed this trait did what farmers have always done with a lucky break. They seized it, saved it, and bred for it generation after generation. Slowly, the teosinte stalk begins to change shape. The kernels grow larger. The husk begins to wrap protectively around the ear the way we recognize today. Somewhere in these hills, Early people are also discovering something else about this odd little grass. If you crush the stalk, sweet juice runs out, almost like sugarcane. Some researchers now believe that long before anyone valued the grain itself, people were chewing teosinte stalks for that sugary sap, or even fermenting it into one of humanity's earliest alcoholic drinks. In other words, corn may have started its relationship with humans not as bread, but as a buzz. Imagine one farmer among them. We don't know her name, no one recorded it because no one yet knew they were making history. She kneels in damp soil at the edge of a clearing, her hands stained green from stripping husks, her knees aching from a lifetime of this same motion. She is not thinking about the future of human civilization. She is thinking about her children's next meal, about the small, hard cobs drying on a woven mat beside her, about which handful of seed looks fullest, plumpest, most worth saving for next season. She has never seen a plant transform. She will never know that her small, unglamorous choice, this cob, not that one, is a single frame in a film that will run for 9,000 years. Multiply her by 10,000 farmers across 200 generations, each one making the same quiet, patient decision, and you get modern corn. There is no single inventor of maize. There is only an unbroken chain of ordinary hands, each one trusting the next. By roughly 6,000 years ago, cobs are showing up in the archaeological record in Oaxaca. Maize pollen is showing up along the Pacific coast and as far away as Panama. This plant, born from a nearly inedible weed in one river valley, is already on the move, carried in the pouches and memories of migrating farmers, crossing mountain ranges, adapting to new soils, new elevations, new rainfall patterns. By 6,700 years ago, it has reached Peru. Every step of this journey required something remarkable. Farmers who understood, without any concept of genetics, that they could reshape a living organism simply through relentless, patient selection. They were not scientists. They were something rarer, multi-generational engineers, working in a laboratory made of dirt and sunlight, with results measured in centuries. But here is where the story takes its first true turn, the discovery that will explain everything that happens later, including that mill town in South Carolina. As maize spreads across Mesoamerica and becomes the foundation of daily life for the Olmec and later, spectacularly, for the Maya and the Aztec, the people who depend on it stumble onto a problem. Eaten plain, corn is deceptive. It looks nourishing. It fills the stomach. But something in its chemistry locks away one of its most important nutrients, niacin, in a form the human body cannot absorb. A population that eats corn as its overwhelming staple, without correcting this flaw, will slowly starve for a vitamin even while their bellies are full. It is one of nature's cruelest tricks, abundance that conceals a hidden deficiency. Somehow, and we still do not know exactly when or by whom, Mesoamerican cooks discover the fix. They begin soaking and cooking their corn in an alkaline solution, water mixed with ash or crushed limestone. This process, later given the name nixtamalization, does something almost magical at a molecular level. It breaks down the corn's tough outer layer, softens it for grinding, dramatically improves its flavor, and, crucially, invisibly, unlocks the niacin trapped inside, making it available to the human body for the first time. The people who discovered this almost certainly had no idea why it worked. They knew only that it worked, that corn treated this way made for better dough, better flavor, better health. And so this technique becomes woven permanently into Mesoamerican cuisine, the invisible foundation beneath every tortilla, every tamale, every bowl of masa for thousands of years. It is, quietly, one of the most important food processing discoveries in human history, and almost nobody outside of food science has ever heard of it. Fueled by this crop and this knowledge, extraordinary things begin to happen. Maize becomes the economic and spiritual backbone of Mesoamerican civilization. The Maya do not just eat corn, they build entire mythologies around it. Their creation story tells of the gods failing twice to make humanity. First from mud, which crumbled, then from wood, which had no soul, before finally succeeding by shaping the first true humans from maize dough itself. Human beings, in the Maya imagination, are literally made of corn. Later, the Aztec Empire rises on the same foundation, its markets overflowing with maize in a rainbow of colors: white, yellow, red, blue, black. Its tribute systems demanding maize from conquered cities. Its calendar and rituals tracking the corn planting season with the same precision Europeans reserved for the liturgical year. An empire built kernel by kernel. Walk for a moment through the great marketplace of Tenochtitlan, the Aztec capital rising from an island in the middle of a lake, a city so vast and so orderly that the conquistadors who eventually saw it compared it, in stunned disbelief, to the greatest cities of Europe. The air is thick with wood smoke and the sound of hands slapping dough into flat rounds against clay griddles. Vendors call out over pyramids of dried kernels sorted by color, each shade destined for a different dish, a different ritual, a different season. Women grind soaked, alkaline-treated corn into masa on volcanic stone, the same nixtamalization technique perfected centuries earlier, the motion so practiced it looks less like labor and more like music. Steam rises from tamales wrapped in corn husks. Priests use kernels in divination rituals, reading fortunes in how they scatter across a woven mat. Tribute runners arrive from distant provinces hauling sacks of maize on their backs. Taxes paid not in coin but in grain, because in this empire, grain is currency, grain is power, grain is survival. An empire of hundreds of thousands of people, with an economy, a religion, and a calendar all built, in one way or another, around a single domesticated grass. And none of it, not the pyramids, not the markets, not the astronomers tracking planting seasons in the stars, would have been possible without those anonymous farmers in the Balsas Hills, choosing one cob over another 300 generations earlier. And then, in 1492, everything changes again, though almost nobody involved understands the scale of what is happening. Christopher Columbus's men, exploring the coast of Cuba, encounter a plant unlike anything in Europe, tall, golden, strange. They bring samples back to Columbus. It is the first recorded European contact with maize, a plant so unfamiliar that Europeans will eventually take its name from the Taino word maize. Within decades, Spanish and Portuguese ships are carrying maize seed across the Atlantic, and then further still into West Africa, into the Mediterranean, into Ottoman territory, eventually into China. In a matter of a few generations, a crop that had taken 9,000 years to spread across 2 continents by foot and canoe circles the entire globe by sail. This is one of history's great ironies. The so-called Columbian Exchange is often remembered for what Europe brought to the Americas: horses, steel, disease, devastation. But maize was one of the greatest exports flowing the other direction, and it would go on to prevent famines, feed empires, and fatten livestock on every inhabited continent. In West Africa, maize arrives almost like a miracle crop, thriving in soils and rainfall patterns that had frustrated older staples. And within a couple of centuries, it becomes a dietary backbone from the Guinea coast to the Congo basin, feeding population growth that reshapes the demographic map of an entire continent. In southern China, maize climbs into hilly, marginal terrain where rice paddies could never take hold, opening whole new regions to farming and helping fuel a population boom that would eventually make China the most populous nation on Earth. In the Balkans and Italy, Maize becomes polenta, a peasant staple so central to daily survival that entire regions of Europe restructure their agricultural calendars around it. Within 2 centuries of Columbus's first sighting of the crop on a Cuban beach, maize is quietly feeding more people on more continents than almost any plant in human history. A scale of influence its original Mesoamerican breeders, working seed by seed in a river valley, could never have imagined and could never have intended. But something was lost in translation. When European farmers and cooks adopted maize as a cheap, reliable staple crop for their own poor and their own colonies, they took the seed, but not always the knowledge. Nixtamalization was a Mesoamerican technique, developed and perfected over millennia specifically because Mesoamerican diets depended so heavily on corn. European peasant farmers growing maize in Italy, Spain, and the Balkans as a supplement rather than under that same ancient dietary logic mostly skipped it. For a while, this didn't matter much because maize was just one part of a more varied diet. But wherever maize became the overwhelming, disproportionate center of a poor population's diet, without the alkaline treatment that unlocked its hidden nutrition, a slow, mysterious illness would eventually follow. It appeared first in Spain in the 1730s. It appeared in Italy, where its name may have come from pellagra, rough skin. And 2 centuries later, it would appear with terrifying force in the American South. Which brings us back to that cotton mill town and the missing piece of the puzzle. By the early 1900s, cornbread had become the caloric backbone of poor Southern life. Cheap, filling, endlessly available, eaten by sharecroppers, mill workers, prisoners, and orphans, often with little meat, milk, or fresh vegetables to round out the diet. Making matters worse, a new industrial invention was quietly stripping away what little nutrition remained. In 1901, an Illinois inventor patented a machine called the corn degerminator, designed to remove the germ from corn kernels so that cornmeal would last longer on store shelves without turning rancid. It worked wonderfully for shelf life. It was catastrophic for health, because the degerm process stripped out much of the corn's remaining niacin along with the germ, and this industrially milled meal spread rapidly across a region already eating enormous quantities of corn with no nixtamalization at all. The disease that had haunted poor corn eaters in Europe for 2 centuries now had the perfect conditions to explode. And explode it did. By 1909, pellagra had been reported in 26 states, killing at least 10 people a day. In South Carolina alone, one report recorded 30,000 cases in a single year, with a horrifying death rate near 40%, making it the second leading cause of death in the entire state. Doctors were desperate and wrong, because pellagra clustered in overcrowded institutions, asylums, orphanages, prisons, mill villages. Most physicians assumed it was contagious, an infectious disease spread by filth or germs, and the medical establishment searched fruitlessly for a microbe that did not exist. In Arkansas alone, in a single year, 1927, more than 600 people would die from this disease. Ordinary farm families found listless and confused in their own kitchens, children too weak to walk to school, mothers whose skin had turned raw and scaled across the backs of their hands and necks. The exact patches of skin left bare and exposed to the sun, in a cruel coincidence that convinced some doctors, wrongly, that pellagra was somehow related to sunburn. Neighbors, terrified and uncomprehending, began quietly avoiding pellagra households altogether, afraid to sit at the same table, afraid to let their children play together. In a wave of stigma, one historian would later compare directly to the shame and isolation faced decades afterward by the earliest AIDS patients. Nobody in these rural communities knew that the cure, when it finally arrived, would be almost embarrassingly cheap. Brewer's yeast, rich in niacin, distributed by the Red Cross, curing thousands of cases within weeks once doctors finally understood what they were treating. an entire regional health catastrophe, prevented for pennies a day, if only anyone had known sooner. Enter Dr. Joseph Goldberger, a Hungarian-born epidemiologist with the U.S. Public Health Service, who suspected something the rest of the medical world refused to consider. That pellagra wasn't caused by infection at all, but by diet. Goldberger toured a Georgia asylum where pellagra ravaged patients but never touched the staff, even though staff and patients technically ate in the same cafeteria. His breakthrough observation was almost embarrassingly simple. The staff ate first and took the fresh meat and milk before it ran out. The patients got what was left, mostly corn. To prove his theory beyond doubt, and to overcome the era's rigid disbelief, Goldberger ran a chilling experiment at the Rankin State Prison Farm in Mississippi in 1915, recruiting healthy volunteer inmates with the promise of pardons, and feeding them a corn-heavy diet stripped of fresh protein and vegetables. Within 5 months, 6 of the 11 men had developed the telltale rash of pellagra. To silence remaining skeptics who still clung to the germ theory, Goldberger and his colleagues went further still, deliberately swabbing pellagra patients' nasal secretions into their own noses and throats, even swallowing capsules containing scabs from pellagra rashes, at what Goldberger grimly nicknamed his filth parties. None of them got sick. It was unmistakably a disease of nutrition, not infection, and its cure, doctors would eventually confirm, was as simple as adding niacin-rich food back into the diet. Goldberger never lived to see the final scientific confirmation, dying of cancer in 1929. But by the 1930s, the missing nutrient had been identified precisely. Niacin, vitamin B3, the same compound quietly unlocked by a technique Mesoamerican cooks had perfected thousands of years earlier, half a world away, using nothing more than crushed limestone and water. An ancient discovery, forgotten in the crossing of an ocean, cost the American South 100,000 lives to relearn. While pellagra was quietly devastating the rural South, an entirely different revolution was brewing in the cornfields of the Midwest. One that had nothing to do with nutrition and everything to do with yield. For roughly 70 straight years after the Civil War, American corn farmers were stuck. Average yields hovered stubbornly between 20 and 30 bushels per acre, generation after generation, no matter how hard anyone worked the soil. Then, in 1908, a little-known botanist in New York named George Shull, experimenting with self-pollinated corn lines while trying to replicate the genetics of Gregor Mendel, stumbled onto something unexpected. When he crossed 2 separate pure inbred lines of corn, the offspring didn't just match the parent plants, they dramatically outperformed them. He had rediscovered, in agricultural form, a phenomenon now called hybrid vigor. It was a quiet scientific curiosity for over a decade, until a young Iowa farm editor named Henry A. Wallace, grandson of the founder of an influential farm journal, and a man obsessed since childhood with genetics and soil, began experimenting with the same idea on his own family land. In 1923, his hybrid cross, nicknamed Copper Cross, won the Iowa corn yield test outright. In 1926, Wallace and a handful of partners founded a small company devoted entirely to selling hybrid seed corn. A company that would later be renamed Pioneer Hybrid. There was just one problem: nobody wanted to buy it. For generations, farmers had saved seed from their own best plants every autumn, for free, exactly as their fathers and grandfathers had done. The idea of paying real money every single year for seed corn struck most farmers as absurd, even insulting. Wallace's company nearly went broke in 1927, and again during the darkest years of the Great Depression in 1932. What finally broke the resistance wasn't a sales pitch. It was catastrophe. The Dust Bowl years of 1934 through 1936 brought devastating, sustained drought across the Corn Belt, And in field after field, farmers watched their traditional open-pollinated corn wither and fail while the strange new hybrids, planted in test plots right alongside them, kept standing. Picture an Iowa farmer in the summer of 1936, standing at the edge of his own field under a sky bleached white by drought, watching his family's traditional corn. The same seed his father and grandfather had saved every autumn for decades, curl and brown under a sun that hasn't relented in weeks. Then he looks across the fence line at a small test plot of the strange new hybrid seed a company salesman had talked him into trying almost as a joke. Those stalks are still standing, still green, still setting ears. He has spent his whole life believing that paying for seed corn was something only a fool would do. That single afternoon, staring at two fields under the same merciless sky, changes his mind, and his neighbor's mind, and his neighbor's neighbor's mind, faster than any advertisement ever could. In 1936 alone, in the middle of one of the worst droughts in American history, hybrid corn doubled yields compared to traditional varieties in side-by-side trials. That was all the proof skeptical farmers needed. In Iowa, hybrid adoption exploded from a mere 6% of corn acreage in 1935 to 50% by 1938, and to nearly total adoption by 1942. National yields, flat for 70 years, began climbing and never stopped. 40 bushels an acre by 1950, then climbing decade after decade through new breeding techniques, better fertilizers, and eventually genetic engineering, until, a century later, some of the very same Iowa counties where Wallace ran his first tests were harvesting well over 200 bushels per acre, 7 or 8 times what their great-grandfathers pulled from the same dirt. That explosion in yield did something no one fully anticipated. It created a structural surplus of corn so enormous that American industry and agriculture had to invent entirely new uses just to absorb it. Corn stopped being simply a food crop and became something closer to a raw industrial material, endlessly processed, fractionated, and reassembled into forms its ancient domesticators in the Balsas Valley could never have imagined. In 1957, 2 American chemists discovered an enzyme that could convert the glucose in cornstarch into fructose, creating a new kind of liquid sweetener. It sat mostly unused for over a decade, until history handed it an opening. Sugar shortages and price spikes in the 1970s, driven partly by the fallout of the Cuban Revolution disrupting global cane sugar supplies, sent food manufacturers scrambling for a cheaper alternative. High-fructose corn syrup was ready and waiting. Companies like Archer Daniels Midland raced to expand corn wet milling capacity, and by the 1980s, Coca-Cola and Pepsi had both switched their signature drinks from cane sugar to corn syrup across the American market. A grass from a Mexican riverbank was now, quite literally, sweetening the most consumed beverages on the planet. And the transformations kept coming. In the mid-2000s, in the name of energy independence and rural economic policy, the United States government mandated that gasoline be blended with biofuel, and corn-based ethanol became the overwhelming source of choice. Almost overnight, a third of the entire American corn crop began flowing not into food at all, but into fuel tanks, a staggering diversion of farmland that would have been unthinkable to the Depression-era farmers who once resisted even buying hybrid seed. Today, the accounting of a single American corn harvest reads almost like a strange industrial recipe. Roughly a third of it burned as ethanol fuel, well over a third fed to cattle, hogs, and poultry, a smaller portion exported around the globe, and only a modest slice, a mere few percent, turned into the sweeteners, starches, and cereals that actually end up as recognizable food on a dinner table. The plant that once fed Aztec markets and saved starving pilgrims now, more than anything else, feeds engines and livestock. Speaking of those pilgrims, we have to rewind one more time, because corn's American story very nearly ended before it began. When the first English colonists arrived at Jamestown in 1607, they encountered a grain entirely unknown to them, so unfamiliar that they simply borrowed their word for wheat and other cereal grains and called it corn, a generic term that, in England, had meant almost any staple grain at all. They were astonished by what they found. Virginia's indigenous farmers were pulling far more food from far less land than English agriculture back home ever managed, using an ingenious three-part planting system that English eyes had never seen. Corn, beans, and squash grown together in the same mound, a method later called the Three Sisters. The corn stalks grew tall and gave the bean vines something to climb. The beans, in turn, pulled nitrogen from the air and fed it back into the soil for the hungry corn. And the broad squash leaves spread across the ground below, shading out weeds and holding moisture in the earth. Three plants planted as one, each solving a problem for the other two. An agricultural system so elegant that it required no plow, no fertilizer, and no machinery, only patient observation refined over centuries. 13 years after Jamestown, in the brutal winter of 1620, a second group of English colonists arrived off the coast of Massachusetts aboard the Mayflower, and they were not so lucky. Blown off course, landing in a colder climate than they had planned for, with stony soil and no experience farming it, nearly half of the roughly 100 colonists died before spring. The survivors of Plymouth Colony were saved not by any skill they carried from England, but by the direct intervention of two native men, Squanto and Samoset, who taught them how to plant corn using the Three Sisters method, and who showed them a trick passed down through generations of coastal farming: burying fish alongside the corn seed as natural fertilizer to enrich New England's thin, sandy soil. Squanto's own story carried a bitter irony. Years earlier, he had been kidnapped by an English sea captain and sold into slavery in Europe, only to make his way back across the Atlantic and find his own village wiped out by disease in his absence. And yet it was this same man who handed the surviving pilgrims the knowledge that let them live. That autumn's harvest, built on indigenous corn and indigenous agricultural science, became the meal we now celebrate every November as the first Thanksgiving. Without corn, and without the people who already understood how to grow it in American soil, there very likely is no Plymouth Colony success story to tell at all. There was another use for surplus corn that frontier farmers discovered almost by necessity, and it would go on to become one of America's most iconic exports. In the hill country of Kentucky and Tennessee in the late 1700s, corn grew easily, but hauling raw grain over mountain roads to distant markets was slow, expensive, and often not worth the trip. Farmers realized they could solve the problem by concentrating their harvest into something smaller, more valuable, and far easier to transport: whiskey. A wagon load of corn might be worth little after a brutal overland journey, but distilled into liquor, aged in charred oak barrels, that same corn became a commodity worth fighting to protect, literally, in the case of the 1794 Whiskey Rebellion, when farmers in western Pennsylvania took up arms against a federal tax on the very spirit their corn harvests depended on. By law, bourbon must still be made from a mash that is at least 51% corn, a requirement that quietly ties every bottle on a modern liquor store shelf back to the same grain the Wampanoag once buried with fish to feed the starving pilgrims. Whiskey, cornbread, tortillas, tamales, popcorn at the movies, the same plant, wearing 100 different disguises. From those first fragile harvests, corn wove itself into the deepest fabric of American life, for better and for devastating worse. It fed the westward expansion of settler farms across the frontier. It fattened the hogs and cattle that built Midwestern fortunes and Chicago's meatpacking empire. And in the plantation economy of the pre-Civil War South, it became, tragically, one of the primary rations issued to enslaved people, a cheap staple whose caloric abundance masked its nutritional gaps, the very gaps that would resurface decades after slavery's end, in the pellagra wards of the segregated South. The same crop that built indigenous civilizations, saved starving colonists, and later killed thousands through hidden malnutrition, was also quietly and painfully bound up in the machinery of human bondage. Corn does not carry a single, simple moral story. It carries all of American history at once: survival and exploitation, abundance and neglect, ingenuity borrowed and ingenuity forgotten. So look at where that 9,000-year journey has actually landed us. Corn is no longer simply a plant you can point to in a field, though American farmers still plant roughly 90 million acres of it most years, an ocean of green stretching from Ohio to Nebraska, visible from space as a single continuous quilt of cultivation larger than the entire country of Germany. It is in your fuel tank, quietly making up around 10% of the gasoline burned by American cars. It is in the bodies of the cattle, chickens, and pigs behind most of the meat in a supermarket, since the overwhelming majority of the corn crop never becomes human food directly but livestock feed instead. It is in the syrup sweetening sodas around the world, even as public backlash over the past 2 decades has finally started to push high-fructose corn syrup consumption down from its peak. It is in the cardboard of shipping boxes, the starch behind pill capsules, the glucose in hospital 4 bags, the biodegradable plastic in some food packaging, and the pure, boiled, buttered kernels still served on paper plates every county fair from Iowa to Georgia. Almost no other single organism on Earth has burrowed this deep into a civilization's economy, medicine, energy grid, and dinner table simultaneously. Wheat feeds people. Cotton clothes people. But corn, in the modern American economy, does almost everything at once. And most people never stop to notice because it hides in plain sight, disguised as 100 different products under 100 different names. Stand today at the edge of a modern Iowa cornfield in late July, and the scene looks almost nothing like that anonymous farmer kneeling in the balsa's mud 9,000 years ago. And yet it is the exact same act, carried to an almost unimaginable scale. Stalks stretch to the horizon in perfectly straight rows, each one engineered down to the genome, some varieties modified to produce their own resistance to pests, others bred to survive being drenched in herbicide that would kill any weed unlucky enough to compete with them. A single air-conditioned combine harvester, guided by GPS accurate to inches, can strip and shell more corn in one afternoon than an entire Mesoamerican village could have processed by hand in a full season. The seed itself is no longer saved from last year's harvest at all. It is purchased fresh each spring from one of a small handful of global agribusiness giants, a direct, unbroken descendant of the very same business model Henry Wallace had to fight so hard to convince skeptical farmers to accept a century ago. What was once a radical, unwelcome idea is now simply how corn is grown almost everywhere on Earth. That scale has not come without controversy. Genetically modified corn, along with the herbicides and monoculture farming practices that go with it, remains one of the most contested subjects in modern agriculture, with passionate arguments on both sides about environmental impact, corporate consolidation, biodiversity, and the long-term health of the soil itself. Independent family farms have shrunk in number even as total corn output has soared, and questions about who truly benefits from the modern corn economy, the farmer, the processor, or the boardroom, remain very much unresolved. The story of corn's astonishing productivity is inseparable from the story of who controls it, and that argument is still being fought out in courtrooms, legislatures, and farm kitchens today. And still, the story is not finished being written. Scientists today are racing to breed and gene-edit new corn varieties that can survive the hotter, drier growing seasons a changing climate is already bringing to the Corn Belt, chasing the exact same instinct that drove those first anonymous farmers along the Balsas River 9,000 years ago, patiently selecting for whatever trait might help the plant, and the people who depend on it, survive one more season. Researchers experimenting with closed-loop agriculture for future space habitats have tested corn as a candidate crop for growing food aboard long-duration missions and future off-world settlements, betting that a plant tough enough to conquer nearly every climate on Earth might be tough enough to help humans survive somewhere far stranger. It is a strange, fitting possibility for a species that began as an unpromising, stone-hard wild grass nobody would have looked at twice, and ended up, through 9,000 years of human patience, catastrophe, forgotten knowledge, rediscovered science, and relentless reinvention, quietly running the modern world, one kernel, one field, one continent at a time. The next time you twist open a bottle of soda, fill a car with gas blended at the pump, or bite into a warm, buttered ear of corn at a summer cookout, remember what you're actually holding. The descendant of a nearly inedible weed from a Mexican riverbank, reshaped by nameless farmers over 300 generations, worshipped by empires, carried across oceans, forgotten in translation until it cost 100,000 lives to relearn, and rebuilt again by science into the single most influential crop on the planet. Corn didn't just feed civilization. In more ways than most of us will ever notice again, corn quietly became civilization.